Hello, thank you again. What I want us again is still on the angle properties of a circle. Just want again to provide yet another example so that maybe this question can foster our understanding on this area of angle properties of a circle. So I've provided a question, and the question goes that in the figure below, ABCD is a cyclic quadrilateral. Point O is the center of the circle. And then also you are told that angle ABO is 30 degrees. That is angle ABO is 30 degrees, you can see there. And then secondly, you're also told that angle ADO is 40 degrees. So they are telling you to calculate the size of angle BCD. BCD. Remember, from this point, just want us to master this particular part. A cyclic quadrilateral. So a cyclic quadrilateral is a four-sided figure like this one, a four-sided figure where the vertices lies on the circumference of the circle. That a four-sided figure inside a circle whose vertices lies on the circumference of the circle. So for such angles, we agreed that opposite angles of a cyclic add up to 180. So if I was to take these two angles, this one and this one, they should add up to 180. So to work out this particular equation, there's some modification you can do to the diagram. You can drop this perpendicular line, which is another radius to the center. So this one and these ones are radius, and therefore this angle is going to be 40 degrees. 40 degrees reason is base angle of isosceles triangles are equal. Similarly, this one is a radius to this, and therefore this angle also is going to be 30 degrees here. Base angle of isosceles triangle. So the whole of this angle, therefore, is going to be 70 degrees. If you look at this, 70 degrees. The whole of this, because we'll talk of 40 plus 30. Now, since this is a cyclic, then this angle A and angle C should add up to 180. So if this is 70 degrees from 180, it's 110 degrees. Not 110 degrees. This is going to be 110 degrees because they are opposite angles of a cyclic. The same question can also be done this way, because you already know this. This is 40. This particular angle is going to be 100. If you look at this particular angle is going to be 100. Similarly, this angle is also going to be 120. Why 120? Because if this one is 30 from 180, this is 120. Similarly, if this is 40 from 180, this is 100. So the angle above here, this one, is 220. So 220, we can still use that concept that angle at the center of a circle are twice that of the circumference. So if this angle is 220, then it tells you that this angle is 110 degrees. So there are two approaches you can actually use for that one. That was just a discussion, but we can move on with the same now on the solution part. I've tried to provide that clear solution there. Now, what I've already said is the same. That one thing we agreed is that I'll drop this perpendicular or this line to the center, which is also a radius, and this one is a radius, so this angle will be 40, 40. Why 40? 40 here and 40 here, because they are base angle of isosceles triangle. Similarly, this one and this one is a radius, and therefore, if this is 30 degrees and also this is 30 degrees, which therefore tells you that this angle is 70 degrees, and therefore this angle at the center is twice this particular angle on the circumference. So this angle will be 140. Once we know that that angle is 140, angle at a point add up to 360. So the upper angle will be 220 up here, 220. And because this angle is twice this one, so this angle will be a half of 220, which is 110. Or if you don't want to say that, you can talk of opposite angles in a cyclic quadrilateral add up to 1. 80. So if this angle is 70 degrees up here, then this angle will be 110 degrees. So you'll say that angles BCD equals to 110 degrees, and the reason for that one is angle at the center of a circle are twice that on the circumference. Or another reason you can talk about is angle in a cyclic quadrilateral add up to 180. Remember, this question appeared in KCSE 2011, paper 2, number 5. So follow me, and also remember to subscribe so that you can be updated on more interesting video regarding to mathematics. I appreciate and be blessed.